I will be talking about web automation in Python. And first, I'm going to do a brief introduction about the problems that people face today in web automation and possible solutions for that. So about me, I automate things. Right now, I work for iBoss, a company in downtown Boston. I do DevOps and web automation there. I've also worked for HubSpot and Veracode as well. And testing is what I do, and I've used automation for several different tasks, such as data extraction, customer support, migrating data from one website to another, and all that. So I'm going to get to those tools in a bit. So first things first, what is Selenium? Now, many people here are probably familiar with the term. It's a browser automation library for interacting with web applications, and it's also known as Selenium WebDriver. So that's nothing new there. Next, let's see. Selenium is not a standalone test framework. So this means that Selenium, right out of the box, does not have a framework that makes it more useful for testing, such as for organizing tests. It's not a complete tool for end-to-end testing, which means if you want to use Selenium and you import that library into your tests, it's going to require a lot of additional work to use correctly unless you already have a framework as a starting point so that you can do a lot of other things that I'm going to talk about. So why is browser testing useful? So unit tests have limited coverage. Different web browsers can display the same HTML differently, and browser tests interact with apps. Well, the browser tests can interact with apps the same way customers do, and that's why you want to be able to test your web applications with actual browser tests, not just unit tests, which won't necessarily help you find all the issues that a web app may have. So here are the common issues that people face today when dealing with web automation. Automation can be slow. Automation can be flaky, unreliable. It can be tricky to write and maintain scripts. It can also be tricky to read other people's scripts. So if you didn't write it yourself, it can be like a big mess of code to understand. And there can be a lot of time-consuming setup. These are like some of the issues that people face today when wanting to write web automation for regular testing or any other type of automation. So to start off, it can be slow. And a common thing that developers do in order to, say, prevent flaky tests is they'll hard code sleep statements into their tests. So for instance, in Python, there's the time library, which includes the sleep method. And you'll basically sleep for a certain amount of seconds to make sure that things have loaded. And methods like this are very inefficient because you might be waiting a lot longer than you need, and it leads to slowing down tests. And it's just one of the ways that developers who write test automation, one of the things they do in order to prevent flaky tests. The other issue is that it can be flaky because there's usually unexpected behavior when interacting with elements on a web page that haven't finished loading. Sometimes there's JavaScript that loads after you go to a web page, and that JavaScript may add a button. But if your automation tries to click that button before the JavaScript has made that button appear, then you could have a flaky test, meaning, oh, the automation looked for a button, it wasn't there, and then the test failed immediately because it couldn't find the button that it wanted to click on. So flakiness is a common issue in dealing with automated tests. Another is that it can be tricky to read and write scripts. I don't know if you can see the screen clearly, but this is a common WebDriver method, and it's very long and it can be very confusing. So you'd have a command such as the driver find element by CSS selector, And then this could be like the tag name, which counts as a CSS selector. And then if you want to like type in text into that field, you'd use the send keys method and then text that you'd type into that text field. Now that's kind of long and messy, and that can be improved on if you're using Selenium. So for instance, if you're using a framework such as Selenium Base, which I'm getting to, it'd be a simple command such as self.type, the CSS selector, and the text that you would enter into that text field. So something that regular Selenium has, the regular Selenium WebDriver, it can be a long, messy line of code. If you want to like write a command to type in text, you can simplify that down to something shorter, which Selenium Base will do, and I'm going to get to that shortly. Also, another common thing is that there is time-consuming setup. So meaning if you don't have a pre-built end-to-end test framework, you have to take in additional time for test management, so like organizing the tests in such a way that you can run them from a script. Browser management, meaning that like if you immediately start running, before you can like click a button on a web page, you have to spin up the browser. And before you spin up a browser, you have to install something called Webdriver. And Webdriver comes in different flavors, such as Chrome driver, Gecko driver for Firefox. Chrome driver is the driver you need to spin up a Chrome browser. There's also Safari driver, or the new, I think it came out just last year, Microsoft Edge driver, which allows you to do automation on Microsoft Edge. So for every single web browser that you want to automate with WebDriver, you have to first go to the website and download the driver, and then inside your test, you'd have to then call that. Instead of having to do all that, Selenium Base will simplify that by automatically managing the downloads of drivers and spinning them up automatically when a test begins, so that you can jump immediately into opening a URL and say clicking a button on a web page. So browser management, that is a pretty complicated thing that WebDriver or Selenium WebDriver doesn't really like do much for you when you get it right out of the box. So that's one of the issues that lead to time-consuming setup. Another thing is that you don't get any type of logging and report generation when you download Selenium WebDriver, because there's no reporting system there, there's no logging system, there's no dashboards or storing screenshots or anything like that out of the get-go. You'd have to create your own framework that basically processes lines from your tests and creates logs and reports out of that, as well as a dashboard. So these are some of the things that you don't get with Selenium on its own. There's no logging, no report generation, no dashboards or nothing like that. And those are very key things that anyone would want if they want to like keep track of like what tests have been run, which tests failed, what's the stack trace or screenshots from those tests, etc. And also there's nothing for automatic CI setup or DB setup, etc. Meaning that if you download like just raw Selenium WebDriver, you have to start building out all these scripts in order to run everything in CI easily, or like write test results to a DB, etc. So improving on Selenium, that is where Selenium Base comes in. Now, Selenium Base, as the definition I have here, it's an open source Python framework that makes it easier to write reliable browser automation for testing and more, and includes test management, browser management, reports, charts, dashboards, and screenshots. So with Selenium Base, it's written in Python, and it uses the Selenium WebDriver libraries, but it gives a framework it provides a framework for it so that all the complicated, long time-consuming things can be done a lot more quickly. So you can just install it quickly with Python using the pip package manager. And it's reliable, meaning that when Selenium Base clicks on an element on a page, unlike regular WebDriver, which does not wait for the page to finish loading, Selenium Base will first wait for the website to be fully loaded and the element that you want to click on to be visible and interactive, and only then will it try clicking on it. And that will lead to test reliability so that tests don't immediately break when you try to interact with elements. So there's lots of features built in. It's easy to write scripts quickly. As I said, it's built on top of Selenium WebDriver, and it extends the PyTest unit testing framework, which is one of the, it's Python's most advanced unit testing library, and you can just download it with the pip package manager like you can any other Python package. So that's PyTest, and many people many of you might have already heard of it. It is generally used only for unit testing, meaning it doesn't have anything built in for like interacting with web browsers, clicking on elements, etc. That's where Selenium Base comes in to extend the PyTest unit testing framework so that not only does PyTest manage unit tests, but it can also manage end-to-end browser tests as well. So the setup for Selenium Base is just once you install Python, you get the pip command, and then you can do pip install Selenium Base, and then you can do Selenium Base install Chrome driver, and that takes care of getting Chrome driver, and it puts it in a local folder for Selenium Base so that you can spin up the browser right away. And if you weren't using any type of browser manager like Selenium Base, you'd have to go to the website manually, download the file, put it on your path, etc. There are a lot of steps that you can easily do in just a few lines of code. And this will only work if you already have Chrome installed. If Chrome was not installed, they would just say, hey, Chrome was not found on your system, can't run a test. So make sure you probably have that installed anyway, so I usually don't say it. But sometimes like people only have like Edge installed if they have a brand new Windows machine or something like that. All right, up next. So to try any of the example tests, you can just clone the repo from GitHub. And if you're familiar with Git, many of you probably are, you just do git clone and the location of the Git file. And then you can cd into the folder. And then to run it, you would use PyTest. And you could say run my first test. And then you can specify, say, the browser and plenty of other command line options. I'll cover that when I live demo that later. But essentially, if you don't specify Chrome as the browser, it's the default browser, so we'll use Chrome anyway. You can also use like Edge, Firefox, Safari, even Opera, or you can even connect to an existing cloud service such as Sauce Labs, Browser Stack, etc. Other services that many of you may have heard of. Let's see, so as I mentioned before, Selenium-based methods automatically wait for page objects to fully load before interacting with them, and that will prevent flaky tests. The built-in functionality includes the entire PyTest plugin ecosystem. So since Selenium Base is somewhat an extension of PyTest, anything that PyTest can do, Selenium Base can do as well, because PyTest just takes in Selenium Base as a plugin, and then you have the entire unit testing framework that PyTest already provides. So in that respect, Selenium Base is not reinventing the wheel. It's taking PyTest, a known unit testing framework used by tons of people, and it integrates Selenium WebDriver, which is also a major tool used by many people. And it gets the best of both worlds so that you have the full framework with test organization and test reliability methods waiting for elements to appear, etc., without the raw Selenium flakiness that many people have known to expect when trying to use Selenium on its own without a framework like Selenium Base around it. So you can also easily run tests headlessly through a command line argument. You can change the user agent, the proxy server. You can even run tests in mobile mode. It includes logging and report generation, dashboards, charts, and screenshots. I'll get into that in a bit. And you even have tools for building website components totally unrelated to testing. Like Selenium Base is more than just a test automation framework. It is a tool that you can use to, say, build website tours or charts or presentations. And I'll get into that in a bit. Let's see. So a lot of Selenium Base is accessed by the command line, which means you can set your web browser. You can use demo mode, which can change the speed of a test and show you what a test is actually doing just by watching it. Changing the proxy server, you can send results to a MySQL DB if you want. You can choose a Selenium grid to connect to. Most of these are optional settings, and there are plenty of options that you can select from when you run your tests. So if you want to configure default settings, there is a settings.py file located in Selenium-based config. And if you run python setup.py install from a cloned copy of Selenium Base, you can change, say, default wait times to say, like one of the settings is how long to wait before like timing out a test. Like for instance, if you go to a website and you try to click a button that is never going to show up, the framework needs to know exactly how long you should wait before it gives up and says, okay, I'm going to fail the test because, say, this button did not appear after waiting 6 seconds or 10 seconds. Default values like that are defined in settings.py. So like, what's the timeout value for waiting for an element to appear before fully giving up and failing the test? That would be found there. Let's see, next. So here's a sample Selenium-based script. So this is Python for those of you who aren't familiar. So it'll use this regular import. So from Selenium Base, import base case, and then you would create a Python class that inherits base case. And then inside the Python class that you've created, you will have a method definition. So here I'm calling a test basic. And the first thing it's going to do is open a URL, and then it's going to type this text into this text field. And by default, it's going to use CSS selectors to find elements on a web page that you want to interact with. So for instance, typing in text into a text field or clicking a button, those elements on a page that you want to access, they will all have a CSS selector. And if you're not familiar with CSS selectors, you can go into any web browser, right-click, and then you can click inspect, and it'll be part of developer tools like Chrome, Firefox, all the major browsers have that. And you can pull out the CSS selector and then drop it in there, and then you can immediately access that element. So here's an example.
Michael, could we stop for a moment? There
Sure.
are some questions in the chat.
Sure.
So does the smart wait feature handle lazy loading iframes as well?
Lazy loading iframes, yeah. So there's methods for going inside of an iframe. So if you need to go inside an iframe, that's just switch to frame. And then once you switch to the frame, it'll wait for the iframe contents inside to finish loading before interacting with the elements there. That's going to be in a later example that I'm going to get to. But yeah, switching into iframes is one of the ways you can interact with elements on a web page.
Another question was that can Selenium Base also work with IDs and path as well as CSS selectors?
Yes. So there is an optional argument that I haven't specified here, but when I get to the after the presentation, essentially where you see like type or click into a selector here, by default, it's going to use CSS selectors, but there is a second optional argument where you can change the selector type from CSS selector to class or ID. But the beautiful thing about CSS selectors is that you can represent an ID with just a pound sign, like the bottom line here, where I'm asserting that an element is there. That pound comic, even though that's a CSS selector, that represents the comic ID. And whenever you see like a dot, so for instance, let's see if any of these selectors have that, a value. Anyway, for instance, like a value here, if you click input value equals search, if you had class equals search, that would click on the class. So technically, any selector can be represented as a CSS selector more conveniently than having to use the second optional argument to change which selector type you're using. You can easily represent an ID as a CSS selector by putting a pound in front of it. Or if it's a class name, you put a dot in front of it, and that also works as a CSS selector. Is that, I can't see the questions from this view, so.
Yeah, that's all the questions. Thank you, Michael.
Okay.
The only other thing is that you know that we are not seeing the full screen presentation view, but
I guess
if that's intentional, that's fine too.
yeah, it's tricky because is it big enough for you to see the text?
I think we can see that. Please raise your hand and send a message if you cannot see the text well enough.
Okay, I'm making it so I can easily see the slides and I can easily see who's talking.
Yeah, awesome.
I just can't see the questions. Not
no, don't worry. The text size is fine, so it's readable. Don't worry. Yeah, go ahead. Yeah, please go on. Thank you.
So the main methods, as you see, opening a web page, typing in text into a text field, clicking a button on a page. You can also assert that text appears within a element. Like for instance, H3 is the CSS selector for an H3 tag. You can also assert the title of the web page, basically assert an element on a web page, and assert text. The second argument is optional. So if you just do assert text without the second argument, it'll basically try to see if any of that text appears anywhere on the web page. And if any of these methods fail, for instance, it can't find the button to click or the assert text fails, the test will fail right away, and you'll get a test output. And I'm gonna live demo this later so that you can see this running in real time. So that's basically what a test will look like. You've got all the main methods that you'd want to use when interacting with a web page. There's a lot more methods. There's over 100 right now. There's about like 8 or so that I'm showing here, but there's a lot more methods than this. So these are just like the basics: asserting text, clicking, typing in text into a text field, clicking to go back, asserting, clicking link text, etc. So this is just like one example of a Selenium-based test. So as you can tell, it's written in Python. So if you know Python, you can easily write automation with Selenium Base. And if you don't know Python, well, it's a easy language to learn, and I'll get more into that in a bit. Let's see. So you can run tests with PyTest or nose tests, but for the most part, PyTest is used because that's the de facto unit testing framework for Python. Nose test hasn't received updates in a while, and I basically maintained backwards compatibility with it, but for the most part, you only have to worry about using PyTest with Selenium Base. So here is a line where I run a test with PyTest, and here's where I run the same test using nose tests. It's a different type of unit testing framework that can interact with Selenium Base. Next, let's see. So because it's built on Selenium WebDriver, any WebDriver method can be accessed via Selenium Base with a self.driver prefixed with the WebDriver method. So that gives you access to the entire Selenium WebDriver library. Next, so Selenium Base includes a tool called PyTest HTML. It's a plugin that basically allows you to create reports out of test results. So for instance, I don't know if you can see this here. It's kind of small, but in this particular example, it ran 4 tests. And you can see a dashboard that shows you there. It's really small. You probably can't read it. But 2 tests passed and 2 tests failed. Additionally, with the reports, you get a stack trace. And you probably can't see this, but it's small on the screen. But here is a stack trace where it ran a test that failed on purpose. And here, the element that it was looking for did not exist, and then it failed. And you also get the screenshots beside that stack trace, basically showing you like, here's a stack trace of the test failure, and here's a screenshot so that you know what page you were on when the test failed. I'm going to get into more detail of that shortly, but essentially this is based off of a tool called PyTest HTML, and I just expanded it a bit to add in a pie chart on top of it. But essentially, this PyTest HTML allows you to get or build test reports out of running tests so that you can see the results easily, what failed, what passed, what the stack traces are, and screenshots for the failing tests so that you can like have an idea of what's going on. And also links to log files, but right now this is part of a presentation, not a web page, so I can't click on those right now. Next, so you can run on pretty much any environment, Mac, Windows, Linux, Docker, straightforward. Like here's an example where it ran from a Bitnami instance that I tested on Google Cloud. Here's like a Docker example where you can build a Docker file and just run it within there. It's pretty straightforward. Let's see. I'm gonna probably, I don't know if I have time for that, but it's got other tools built in such as Master QA, which is essentially a hybrid combination of automated and manual testing, where if it runs a test, it's going to have like a window pop up on the screen that you're on after automation performs actions. And then you can say, yes, this passed, or no, this failed. And then at the end of that, it's basically, it'll look similar to Selenium Base, except that there's a self.verify method when you're using Master QA instead of Selenium Base's base case. But Master QA, it just loads Selenium Base and uses all the Selenium Base methods, which allows you to combine the manual and the automated testing so that you can get human verification with automation assistance to help you along the way. Let's see. I'm going to start live demoing things so you can actually see how everything works, because that's where the beauty of Selenium Base is. So I'm going to jump into a screen here. So I'm now in the examples folder, and let me just make the screen a little bigger so that you can see what I'm about to run. Okay. All right, so you should be able to see this. So I'm going to run PyTest myfirsttest.py. So a simple command where I can run a test, and then it's going to find the test, and then it's going to spin up the web browser. And here we are. It's clicking, typing in text into the field. This is basically that first example test that I showed you. It just ran that. So let me actually shrink it so that I can see this. If I were to look at that, sbase print myfirsttest.py. Scroll up. Here we go. Here's that test that it ran. And I have a lot of, basically it opened the URL. It happened pretty quick. I don't know if you could see that well from the screen share. There was some flakiness, but essentially it opened a page, typed in text, clicked it, and then other important things that I didn't get to cover because I didn't have the full test in front of me was that CSS selectors are the default selector that are used, but you can also say there's the optional second argument on pretty much any test method that uses interaction with a page element. So here you'd say by equals by dot partial link text instead of the default, which is CSS selector, which allows you to specify exactly which type of selector to use. But you can pretty much express most of these like IDs and classes and tag names as a CSS selector so that you don't need to have to worry about that second argument to change it. You can also use XPath instead of CSS selectors, and the beauty of that is you don't need to specify XPath because it auto detects if XPath is used because an XPath selector starts with either a /, a dot /, or an open parenthesis. So therefore, I can use the same self.click method with an XPath selector, and it'll automatically know that it's using XPath instead of CSS because XPath and CSS selectors have different unique identifying characteristics, as shown here. So /, open parenthesis. that's how an XPath selector starts. So you don't even have to say that you're working with an XPath selector. And as I mentioned earlier, you can right-click on a web page and click Inspect in order to find either the CSS or the XPath selector to use. So most methods have the optional timeout argument. So for instance, if I'm doing assert element, by default, it's like a small number, like 6 or 10 seconds for most methods. If you want to change the default timeout, so for instance, if you have like JavaScript that won't run for a certain amount of like a while, and you want to give it a longer timeout for the test to perform the action or the assert without failing, you can just specify the timeout as an optional argument. So let's see, next, the Selenium-based methods often perform multiple actions instead of just one. So when I actually use the type method to type text into the selector, it first waits for the element to be visible, then interactive, then it will clear the text field, then it will type in the new text, and optionally, if it will hit enter or submit if the text ends with \n, which represents the new line character. So this is a way of basically one line of code. If you just write in text with a \n, it'll just click submit after it types that in, which is one way of simplifying maybe 5 lines of WebDriver code into a single line. So throughout the years, there have been like some minor changes. So there might be some duplicate method names that do the exact same thing. So in case you get confused, like the open method is the same as the visit method, or like open URL go to. There's going to be some duplicate methods. So don't be confused thinking that it's an entirely different method. It might just be a duplicate naming scheme for a method you've already used. Like I used to have update text instead of type, but I decided to simplify that down to 4 characters instead of however long this is, so that you can like write out the line a bit faster. And just some like minor duplicate things like asserting element, which it was the same as assert element visible, etc. Let's see. What's next? So there's usually more than one way to do the same thing. So when I have a line such as assert text, that is the same as text equals self.getText, say h3, and then self.assert true, that text in the text. So essentially, that one line here is actually simplifying a set of longer lines, which is actually the same as element equals find element, which finds a WebDriver element. The text equals element.text, and you can do self.assert true, that text and text. That one line simplifies both of these. So oftentimes in WebDriver, we have to deal with like a lot of lines to do a little task. You might be able to get away with just doing one line in Selenium Base that takes care of everything for you. So good to know thing. You can assert exact text, which is basically similar to assert text, but it will take the entire value of get text and it has to be a direct match in order to pass. Let's see, so get text, so assert exact text is the same as self.getText and then saying assert true, that equals text, whereas before I used in. So it's just the, you need a more precise match for that. There's also a method such as title equals self.getAttribute, the CSS selector, and the attribute. That's the same as getting the element and then grabbing the attribute title from that element. So as you can see, Selenium Base in that one line simplified what would normally take more lines to do.
Michael,
yes.
If I can interject, there are 2 questions in the chat. One of them, does Selenium Base support implicit, explicit, and fluent wait?
Yes. So with Selenium Base, because it has the automatic waiting built in, no implicit waiting is needed because it already has the waiting system built in that automatically waits for a page object to be fully interactable before clicking on it, which was the whole point of implicit waits in the first place, giving an element enough time to do it. That's already built in with its own methods. You don't need to use implicit waits, and everything is pretty much its own special timeout system in Selenium Base where there is the default timeout. However, if you don't specify, or if you can also change the default timeout by saying timeout equals your exact explicit 15-second timeout is done here. So if you don't specify this second argument, it'll use the default timeout that's defined in a settings file. Otherwise, you can explicitly say, wait up to this many seconds before failing a method.
Another question was that, is there a way to get the names of all the failing tests after all the tests have finished running?
Yes, I will get to that. Actually, let me run the next test. So let's say I have a test suite. So pytest test suite.py, and I'm going to run a set of 4 tests using --rs to reuse the browser session. So it's going to spin up the web browser and run those tests. And if you just run it by itself without an additional argument to build the report, actually, next time I run this, I'll show you the difference. So if you run it as is, you'll see at the very bottom, here's a failed test, test 2 failed, and here's the exception, fake element, this test fails on purpose, or on the second, or this line here, test 4 failed, selenium.common.exceptions, no such element exception. And the test I ran there was, I just open that open test suite, just so that you can see what I'm running. Here we go. So what I just ran was this. So it basically, I had my test suite, and inside this test suite were 4 different tests, and I have 2 of them that I say are just, they're going to fail on purpose so that you don't get alarmed when you run like the example tests and some of them fail. It's to demonstrate like what happens when a test fails. So I just want to let you know. So I have a test that works normally. It opens a web page, it checks that text is there, and it clicks the next button 3 times in a loop, and then asserts text. Here, I raise an exception right away, fake exception, this test fails on purpose, and I'm gonna have that fail. This test will work fine, and then this one here, because it's going to a certain element where I say fake element does not exist, and I'm gonna say if it doesn't find it in half a second, fail the test. So those were the test 2 and test 4 that fail as seen here. And you see it at the very end exactly which tests fail. And it doesn't include the passing test because usually people only care about what's failing so that they can immediately go into what's fixing. But additionally, when running this, you can use something called --dashboard. And you can also use another argument called --HTML equals report.html. So if you run using the dashboard option, it's going to have a dashboard URL that you can go to, and it's going to run those tests right now. So let's see. So while that's running, if I go to a web page and say, let's let it finish. All right, so that failed. I can go to the dashboard. So I have a log path and a generated HTML file with the additional command line options that I specified. Here, if I go to the dashboard URL, you will see that it has the pie chart where I have the 2 tests that passed and the 2 tests that failed. And because it's a HTML file that's created, you can use the Python simple HTTP server to put that on any website you want. So now that you have the pass test and the fail test, and it's updating in real time. So if I got to it right away, you'd see that it initially start untested. Here we have the test that failed, test 2 and test 4, the duration, and also the links to the latest logs. So if I click on that link here, I can say, okay, here are the log files that are generated with the tests. I can click on test 2 and I can say, okay, so there's a screenshot that's generated and it shows me the page that the test was on when it failed. Additionally, I can get the full page source, HTML, which will basically render in the browser as the HTML file, but it's basically just an HTML of the web page that was on without actually taking you to the exact page. So it saved the HTML. Additionally, there's a basic test info.txt file, and that basically shows you the test that was running that failed, the last page that you're on. So here's like XKCD. I didn't talk about it much. It's a web comic. I use that for a lot of the example tests. Many people have probably seen it. That's the last page you're on. That was the web browser we were using. That's the Unix timestamp of when the test failed, which also translates to a date, Wednesday, January 13th, 2021, and the time, and then that was EDT or UTC minus 500. So essentially, and it gives you the traceback that was included with the failing test. And then you see the exception, fake exception, this test fails on purpose. So the stack trace failure info that you get from the dashboard, it gives you links to like the screenshot and all the files that basically provide info for all the failing tests. And you see that there. Additionally, there's another file that I generated called the PyTest HTML report. So if I open report.html, it'll look similar to the dashboard, except that it also includes the stack traces right here and the screenshots right on the report itself. So it's just two different report types of representing the same thing, but instead of having to click off it to get more information, it'll give you like a really big page with like all the stack traces there. It'll show the failed tests first, but I could say like hide that, and now it only shows me the passing tests. So it gives you more control over what you see, and you can see the screenshot right beside the stack trace. You can see what the failure was and the screenshot that was provided. So when you're running it, it's like, okay, great, I've got the whole pie chart, and I can see, okay, here's the stack traces, here's screenshots. I'm pretty much getting all the data that anyone would want to know to exactly know what's going on with the test. Okay, why did this test fail? Oh, I have a screenshot. Oh, something is wrong. I can see it in the stack trace. So quite useful there. Let's see. Another cool thing about Selenium Base is that there are lots of options that you can use. So you type sbase options. Sbase is just like the short form of Selenium Base that you can use on the command line. You can set the browser. Let's see. Use headless mode so that you don't see the browser spin up. There's a thing called demo mode. I'll show that in a sec. What I last used was reuse session. So normally if you don't use that, it's going to spin up a browser and then close the browser and then spin up a new browser for every single test that runs. That can be time consuming, but sometimes you want a fresh browser and that's the default behavior. So if you want to run tests more quickly, I often use -- reuse session or just -- rs. Will basically run each test in the same browser window one at a time. However, if you need to if you log into a website and log out, you might want to delete any like login cookies that might keep you logged into a website. So there's this optional argument -- crumbs, which will delete cookies if you're using reuse session. So you'd only need to use that argument if you use the one before it, which is that. If you're not using that, you don't need to use crumbs because by default, Selenium Base will spin up a brand new browser and it'll be a total clear cache every time. So you can also, other arguments that you have here, maximizing the browser window. We just use -- dashboard, which gives you dashboard.html, which you just saw. And there was also, we used HTML -- HTML equals report.html, which gave you the detailed PyTest HTML report with the screenshots. So those are just two of the many possible options that you can use. Additionally, you can also run a test in mobile mode. So I'll demo that in a sec. You can also, let's see, there's an ad blocker. You can automatically save screenshots at the end of every test. You can check for JavaScript errors after page loads with -- check.js. You can change the start page so that you can set it like on its own right from the command line when a test starts. Let me demo some of these additional options. You might find these interesting. So if I run PyTest, my first test, -- demo, and let me move that out of the way so it spins up the, oh, trying to get this out of the way. All right, here we go. So in demo mode, it's going to show you exactly what the test is checking. So you can actually see it highlighting the elements that it's clicking on, and you'll be able to see what it's asserting. So here I am saying I'm going to assert the text there. I'm going to assert the title, and then it's going to go through and say I'm asserting the CSS selector there. So demo mode basically injects JavaScript onto the web page so that you can see exactly what the test is checking without having to like read the test script. So if your boss wants to know, hey, what is your test doing? You can just run a test in demo mode, and it'll show them exactly what it's looking at and what it's asserting without having to do any additional like it injects the JavaScript, which is a pretty cool feature. Next, you can also run a test in mobile mode. So let's see what kind of tests. Get that out of the way. Let's see.
Two questions here,
Yes.
Michael. Also, we are coming up to the top of the hour, just for you to be mindful of the time as well.
Okay.
Is there a Lure report integration available?
Yes.
I hope okay, that's a quick one. When you say clear cache each time, does that mean on a per run basis, on a per test basis?
So per test. So normally, so what? If I run PyTest test suite without using the --rs, it's going to spin up a brand new browser each time instead of like keeping the same browser window for all the tests, which I was using in order to make it run faster. So here, where I run test suite, it's going to run a test, and then at the very end of that test, it's going to close the browser. And then the next test runs, it's going to spin up a brand new browser with a full clean cache. So that's the difference between running a test by default, a brand new browser window each time, versus with --rs, reusing the same browser session for all the tests. So basically, it continuously runs all it without spinning up a web browser, test finishes, spin down the web browser, spinning up a new web browser, which is done automatically, and then doing all that. If I took that and ran it as --rs, it's going to run much faster than the 33 seconds that this just took, because it doesn't need to spend extra time like spinning down the web browser after a test and then spinning up a new web browser. It just literally chains all the tests together in the same browser window, which makes it run significantly faster, because usually the hardest or the most time-consuming thing is spinning up that web browser and spinning it down. Now it only took 14 seconds instead of 33, and it would be faster if I didn't have Zoom eating up my bandwidth for the internet connection. But essentially, the --rs will let you run any tests, any suite of tests, and keep that same browser window open so that you save time and not having to spin down a web browser. Because every time Selenium Base opens up a brand new browser window, it's a completely clean cache. And that's why there's the additional command line argument --crumbs if you want to clear out the cache when you are reusing the same browser session, because otherwise, if you have any cookies that were already in that browser from the first test, they would hang around for the second test. But I can now like clean those out so that even though it's using the same browser window, the cookies disappeared between the tests, even though it was the same browser window that was running everything. Does that make sense?
Michael, one more question here is that from your experience, are there many instances of flaky behavior? For example, issues with problematic selectors, timing problems. Also, have you found a need for page objects or other test runner helper resources in your test suites? Or is Selenium Base sufficient for all your use cases?
I've used it for pretty much everything. I do have a page object model example that I've used for some tests. So if I go into the boilerplates folder from examples, I've got basically a page objects file. So there's a command space print page objects.py. So it will just print that out to the console, where basically I can create a class page, and then I can store CSS selectors in there. And then a test can basically import the page objects, such as like from page objects, import home page, shopping page, checkout page. And instead of using the CSS selectors, you're using the page objects instead. So that's just one of the ways that you can structure your tests. If, for instance, if you don't want to have to reuse the same selector over and over again, you can create a page object and then have all your tests reuse that. So that's just one of the many ways of structuring your tests. Page objects can simplify that so that you don't have repeated selectors. So that's just in the boilerplates folder. So PWD. So if you clone Selenium Base, there'll be an examples folder, and then inside that boilerplates, which shows you all the page objects. And going to the other question where you're talking about test reliability, because of the Selenium-based smart waiting, automatically waiting for a web page to fully load and an element to be visible and interactive before interacting with it, such as a click, I haven't seen any flakiness anymore with all the new Selenium-based smart waiting built in. This is unlike raw WebDriver, which does not have the smart waiting built in. And if you try to maybe click on an element using raw WebDriver without Selenium-based, you're going to run into flakiness issues because it won't wait for the web page to fully load, because there is a thing called the ready state of a web page. And with regular raw WebDriver, it waits for the web page to be interactive. I take it one step further and wait for the ready state to be complete. That's two different levels of ready state. And I'm not sure why they use interactive for that, but that leads to a lot of flakiness. By waiting for the web page to be ready state complete, that's going to avoid flakiness, because now it's sure that everything fully loaded, or at least mostly, so that the next part of Selenium-based smart waiting, where actually checks that the waits for the element to be visible and interactive, can also complete. So because of all these extra bits of smart waiting added in, that takes away the flakiness. So
Micah, one more question.
yes.
Can Bdd Framework be used with Selenium Base?
Bdd, yes, they're examples of that somewhere. I've seen that online. I just LS'd into the folder here, so I have a lot of examples here. So for instance, if I want to quickly show Selenium-based mobile mode. So I do pytest test Skype site -- mobile -- browser equals Edge. So here's me using Edge, and I'm switching into mobile mode. It's going to spin up a mobile web browser instead of a regular web browser so that it can do mobile testing. So as you can see here, it's only using that, and it's going to simulate. Right now I'm simulating an Android device, and it's using demo mode. I built that into the test. You can see exactly what it's testing, and it's saying like, okay, I'm going to download Skype, and it detects that you are using Android device, because it says like get Skype from Google Play, and then it'll click that, get Skype from Android, etc. So here I've combined a bunch of things: Selenium-based demo mode, so you can see what it's interacting on, and Selenium-based mobile mode, which basically can spin up a mobile web browser in place of a full web browser, which is useful because sometimes you want to do mobile tests on a website, not just a full regular web browser, so that you can make sure that you get an alert that says, hey, download the app from like Google Play, etc. So Selenium-based mobile mode basically takes away all the pain of actually setting up a mobile testing environment, because all you have to do is type -- mobile, as you see right here, and immediately uses the Selenium-based mobile browser. And then here I use the -- browser equals Edge. So I was able to run a mobile browser right from Microsoft Edge. So these are just some of the advanced features. I'm going to quickly, if I type.
One more question here,
yes.
Mike, and then let's, I think, try to focus on the questions at this stage.
All right.
Is switching between browser windows, tabs, and frames supported?
Yes. So if I go to the Selenium-based website, let's see, seleniumbase.io. So I've got a vast API network. Actually, let me go to the GitHub page. So there's seleniumbase.io, which basically allows you to search for the docs more easily. You can also go to the docs from the GitHub page, and actually at the very top of the GitHub page are basically all the important links that you might be interested in. So if we click on API from the Selenium-based GitHub page, you'll see that if you want to say switch to a frame, let's do a search, switch to frame of element, switch to window, switch to default. There's basically methods for switching to frame, switching to an alert, dismissing an alert, accepting an alert. There's over 100 different methods here. You can like save cookies, load cookies, delete cookies. You can change various things, assert the title, tons of different assert statements. You can play with local storage and session storage. So here I am like setting and getting local storage, and here I'm changing session storage, which sometimes an advanced test may need you to modify or set local storage. Additionally, you can inject JavaScript onto the page, which when you saw with Selenium-based demo mode, where it was highlighting elements on a page and showing you what you were testing, it uses JavaScript for that. So there are things you can do that. I didn't really get into a lot of the advanced features, but for instance, let me do a quick one here where cd tours and pytest google tour.py. Essentially, because Selenium Base can be used to inject JavaScript onto a web page, you can also use it to inject any JavaScript library in the world onto any web page in the world instantly. So for instance, with Google, I'm going to create a website tour. And if you can see that, Selenium-based tours, welcome to Google. Click next, type in your query here. So I basically injected JavaScript and I created a website tour that basically walks you through how to use Google. And click here to search next, or click enter. And I'm basically just clicking the button and it automatically navigates you through a web page. So website tours is just one of the advanced non-testing at all things that are part of Selenium Base, where you can basically, instead of just testing things, it's not just Python, it's Python and JavaScript. That's the thing. Unlike most frameworks where they're simply Python or simply JavaScript, Selenium Base is a thing where you can use Python, but you can also inject any JavaScript library you want into any web page. So that now, for instance, in this advanced Google Maps tour, which basically gets Boston Kendall Square, or I can use the arrow keys, I can now create a website tour and it shows me, oh, hey, this is how Google Maps works, the various things, use the menu button, etc. So website tours is just one of the many cool things I built in where you can inject JavaScript into a web page for a website tour. Additionally, I built JavaScript tools within Selenium Base for creating presentations, as well as building charts. So that's actually a really short one. If I do cd chart maker.
Michael, there is a question also.
Yes.
Is there a way to read and assert text present in the PDF?
Oh, yes, there's a way to, I have a test for that. So that's right from the examples folder. So there is test PDF asserts. So pytest, actually, I'll open that first so you can see. Open test PDF asserts. So you'll see what that looks like, because there are a few unique API methods. I'm going to assert the PDF text that this appears here from this URL here, which is a PDF file. And basically, I don't even have to run it. I'll run it just to see. But basically, here's the URL to a PDF. And then here's the text I want to verify. And it technically doesn't need to even open the web browser for that. It can use the API to load that and then verify that the text is there. So that if I run pytest test PDF asserts, then it will, because with this particular thing, it doesn't really need to go to the URL to do an API call. It'll just do the API call on a blank page because it doesn't need to open it in the web browser. It can check it right away whether or not the text is there. Only if you actually need to click on something or actually go to a URL. But for this particular thing, test PDF asserts is running. It loads it, one passed in 19.87 seconds. It used like a direct API call to load a PDF, and then it checked that the text was there. And there's a more advanced one, such as, let's see, I think test Chinese PDF open test. This is a more advanced example where it's using special characters. Assert PDF text, or you can print the text from the PDF. So here's the address of a PDF, and it's going to grab that text and print to the screen. And I'll also show you how you can assert text from that. So if I run that, PyTest, test Chinese PDF, which has special characters, like, because sometimes you're going to deal with non-English characters in a PDF file. It's going to then use the API to load that, and it doesn't even need the web browser for that, but it'll spin it up. And then inside the output, once it loads the PDF and processes the PDF file, it's probably slower with my Zoom connection, but essentially it grabs that, and then it's going to see. Right now, everything's a little slow. Let's see. Well, maybe it couldn't load that particular one right now, but essentially it'll go load the PDF and then, oh, it worked there. It was just probably a slow internet connection because I picked something on like a website that it was tricky to reach. And now you can see the results of the PDF text that it just printed. Took a little longer, but here's the text characters, because that was one of the things I did. I printed out the text characters, and I wanted to assert that the text appeared. Yeah, this took a really long time to run, but essentially I grabbed the Chinese characters from the PDF file, and I asserted that those particular lines were there as done here. So that is another thing of Selenium Base, that it can handle foreign languages. So for instance, let me quickly go into translations. If I, let's see, let's open a Japanese test. Here we go. So here's an example where basically, because Selenium Base has been translated into 10 different languages, instead of from Selenium Base import base case, you can do, for instance, from seleniumbase.translate.japanese import your Japanese base case. And then every single Selenium Base method that you saw in English, it'll have like a Japanese equivalent, or their other languages, a Russian, Spanish, Portuguese, Chinese, French. Essentially, 10 different languages are supported, so you can actually translate or write all your tests in those languages. And when you run the test, so for instance, PyTest Japanese test.py -- demo. So it's going to run it, and it will take all those methods, it will convert it to Selenium Base in English, and it'll also, as you can see, it'll handle all the character sets. So for instance, this is an assert statement checking that that CSS selector appeared, and it's going to use Japanese characters to do it. So even demo mode, every single thing about Selenium Base, fully translated into different languages so that you can run the same test in Chinese, Japanese, Korean, Russian, Spanish, Portuguese, Dutch, etc. It'll run like any other test. And there's also a translator built in. I'll show you that in a sec. So as you can see, I'm asserting that that CSS selector first heading of that appears there. So it's pretty much demo mode, but now in Japanese. I don't know if anyone in the audience speaks Japanese, but yeah, that's what it's doing if you don't understand the test. And there it's checking that Legoland appears when it checked that.
Thank you, Michael. I also want to be respectful of the time of our meetup participants. We are a little bit 10 minutes over time. I don't know if there are any kind of final questions or any kind of final thoughts you wanted to share.
Let's see. I guess if people have questions, so I did not get to cover most of the features that you saw here, but essentially, if you go to the Selenium Base page on GitHub, or additionally, you can go to the seleniumbase.io doc section. There's a link from the GitHub page at the top, seleniumbase.io. It's basically a copy of the GitHub README using mkdocs, which is a tool for building website pages out of GitHub pages. You can now go through the various features. So I covered website tours, which you saw with the Google tour. I talked about some command line scripts, for instance, sbase print, which allows you to just print a test right to the console output without opening the file. I did not get into visual testing, or I briefly covered master QA at the beginning. I didn't get to chart maker. I covered mobile. Reports, you saw the reports. So basically you get dashboards and HTML reports. But if you have any big questions here, the key thing to check out is just go to the Selenium-Based GitHub page or seleniumbase.io. And this top section here is going to guide you to everything you want to see. So for instance, if you are more curious about the different language translations that Selenium Base has and how translating a test works from one language to another, because there's a script that will convert a test instantly, you can use the translate feature. Mobile reports. The reports, that's the big thing that people should just remember to take away from this, that it's very important to have test reports. And if you want the reports that you saw, for instance, that had the pie chart, you can use dashboard. And that's important so that you can build the Selenium-based dashboard that you saw there. And it goes into more detail so that if you need to host it on your own website, you can run a Python HTTP server on a port, and then you can open that page from localhost / the dashboard. Additionally, the PyTest HTML report, very useful because you have screenshots and stack traces built in, and you can even combine all that. So there's actually a lot of documentation because it's impossible to cover everything in an hour. This is more like a 4-hour talk if you want to go through every Selenium-based feature, because it's big. Like the command line scripts, you can essentially, as I saw before, you can use Selenium-based install Chrome driver for when you first run it, so that you can install a WebDriver automatically. That's going to be one that pretty much everyone's going to use. You install Selenium-based, and then you can do Selenium-based install Chrome driver, etc., or Gecko driver or Edge driver, so that you can use the web browsers automatically. You can also build other directories, automatically generate Selenium-based files. I use Selenium-based options or S-based options to print out all the possible options, and I showed you how print works so that you can print out a file to the console. You can translate a test instantly from one language to another, and because there's a one-to-one mapping of Selenium-based methods to every other language, it'll just immediately take your Japanese test and it'll swap in the English test, so that immediately, let's quickly, if I go to
Michael,
Michael,
time.
All right, time's up, but
Thank you.
people go check it out, the Selenium-based website.
If people have questions, is there a way they can reach you?
Yes, you can reach me. There are several ways to reach me. You can reach me on GitHub. You can reach me on Twitter. From GitHub, there are multiple ways to reach me, because now there's a new thing called GitHub Discussions. It's a feature that GitHub recently just released at their major event. You'll see a Discussions tab right here. So if you want to just say something, you can just click on the Discussions link from the Selenium-based GitHub page, and you can post a message. Additionally, there's the, I guess, the Slack channel from the Ministry of Testing that people are on. I will be there. A third way is the Gitter chat, but it's pretty much the same thing as the Slack channel. You can do a private Gitter message or a message to the whole group, etc. It's pretty much the same as the Slack invite link that they probably saw if they're already on the Ministry of Testing Slack channel. So that's 3 things. You can also do Twitter so there's 4 different ways people can reach me, Slack, Twitter, GitHub Discussions, also the Gitter chat, and there's probably more ways if you just search around there, but there's 4 to get started with.
Sounds good. Well, thank you so much for the presentation. And if there is interest, maybe we can do a follow-up on this. I just want to be conscious of our time and several people know how long we typically run these meetups.
Understandable. Are there any more questions in the link? I'm trying to figure out how to
get. No, there is no more questions in the chat. So again, thank you so much for tonight. And again, the recording is going to be hopefully available in the next few days. So look out for that. And thank you all for joining us tonight. I really appreciate that. And see you on the Slack channel. And then, as you said, Michael provided quite a few ways that you can contact him, and it was very, very informative. So thank you all for joining us tonight.
All right. Thank you, everybody.